in the database. In here, we can have a join that is going to join the data coming from few bolts. So as you can see, it allows you to do quite a complex and sophisticated analytics. You can do grouping in here. You can do joins on the data. And most important, you can use it together with Storm. So I mentioned that Storm has the multi-language protocol, and you can use it together with the open source Storm package, which you can download from CRAN, called simply Storm. And it gives you all the plumbing for Storm. So you don't have to go and implement the entire protocol by yourself. You can just download it, and it will make your life much easier. So to give you the example of algorithm, which we implemented in Ad4Game. So one of the problems and challenges in online advertising is to estimate the goodness of the ad. The kind of standard statistic for it is called click-through ratio, which is calculated simply as the number of clicks divided by number of views. And as you can see in here, we have examples of two ads. So the first one has 5 clicks and 30 views. The second one has 50 clicks and 300 views, so 10 times more. But in both cases, if you just simply calculate one statistic, which is called click-through ratio, we'll arrive at exactly the same number, 0.1666. But you can kind of intuitively feel that the second ad, which had 10 times more clicks and 10 times more impressions, we can be more sure that its click-through ratio is around 0.16. The third one, well, the first one, well, we are not really so sure, because perhaps it only had 5 clicks. So, maybe someone just randomly clicked on this ad, and if we give it more traffic, we are not really sure whether, after 10 more clicks, the click-through ratio will drop to something like 0.01%. So one interesting way to do this estimation is to use something like beta distribution, which is a statistical distribution function that allows us, in this case, to estimate the goodness of the click-through ratio. So on the bottom, so you can actually get those graphs if you put them into Wolfram Alpha, which is a computational search engine. So in the bottom one, which is calculated for 5 clicks and 30 impressions, you can see that, well, in both cases, first of all, the mean, the click-through ratio is exactly the same. But in the bottom one, this probability density function is much thicker. And we can interpret it in such a way that we are not really sure whether the mean, the click-through ratio, is indeed in the middle, or maybe it's somewhere a bit farther away from it. In the first case, so this is the distribution for the 50 clicks and 300 views, we can see that this distribution is much more narrow, which we can interpret in such a way as, the mean is probably indeed very close to the real mean. You can see it even better if you do something like bootstrapping in R. So what we are doing in here, we are using the beta distribution to randomly choose the click-through ratio based on the number of clicks and based on the number of impressions, and we do it 5,000 times. So as you can see, with 5 clicks and 30 impressions, we have much more random distribution. And this corresponds directly to this thicker probability density function from the previous slide. With the bigger number of clicks and bigger number of views, the click-through ratio, which we get from the beta distribution, is much closer to the actual click-through ratio. Okay? So this is all in great, but this is just the statistical, the bootstrapping, so without using the real data. But how would you actually do it in R and Storm? Well, using the Storm R package, the implementation of it in real life is very, very easy. All we have to do is just create the new Storm object and implement the Lambda function on top of the Storm object, which has, well, we need to first of all read the input data, which is the S dollar tuple. And from that input data, we read number of clicks and number of views. And then we simply use the R beta function, which does the beta distribution, which randomly chooses one point from the beta distribution with alpha equal clicks and the beta equal views minus clicks. And this is it, pretty much. So as you can see, this example shows you how you can use R, first of all, to create a statistical model of, in this case, estimation of the click-to ratio. But second of all, once you have the statistical model, you can very, very easily just use the same implementation inside Storm. So as you can imagine, it can allow you to save quite a lot of time. I mean, this is a very simple example, obviously, but you can create much more sophisticated and complex applications. But Storm, together with R, allows you to save time because you don't have to re-implement the solution that you already implemented in R. You can simply port it in Storm and reuse it. Now, on the Java side of Storm, the integration is even simpler because pretty much all we have to do is just create this one line. So we just have to specify the name of our R script from the previous slide with our implementation, and just specify that this is the R script that needs to execute the file. And this is it. So I mentioned before that we get some extra features by integrating R into the Storm. Well, first of all, Storm has this ecosystem of the existing software written in it. So we have a number of existing bolts and spouts that allows you to, for example, write into some of the NoSQL databases, such as Redis or Cassandra, or read the data from some of the systems, such as Kafka. So if you port your existing R code, or it doesn't have to be R, it can be Python, or in whatever programming language you are using, to Storm, you get pretty much all those benefits straight away that you can use within your Storm application. So let's say that you want to actually do some analysis in R, and you want to store the output of your analytics inside Cassandra, let's say. Well, you can probably write everything in R. You can download some package and write the output of your analytics in Cassandra, or you can simply port your R script as bold inside Storm and use the existing Cassandra bold to write the data for you. So again, it allows you to save quite a lot of time. And I also mentioned before about the DRPC, which is the Distributed Rpc. You can imagine that, again, you can use it to create like a service-oriented architecture together with Storm. Once you create your program in R, if you would want to put it on the cluster, you can imagine it's going to be probably quite difficult. How do you put R or Python program on the cluster? You have to implement the entire solution by yourself, some kind of framework that will restart the server when the server goes down, and so on and so on. If you just simply implement your R software as a Storm bold, you can deploy it to Storm, and Storm will distribute your existing software on the cluster for you. And then you can use something like DRPC to call your application running on the cluster. Now, from our point of view, there are a few other packages that you can use as well to develop your applications. So the one, I listed a few interesting here, but the one I wanted to mention is called REMM, which allows you to do the extensible Markov model for data stream clustering in R. So the idea in here is that using this package, you can create your machine learning models on the fly. So rather than creating a statistical model and then reusing it, you can actually create it as the new, you can create it and update it as the new data flows through the system. And few interesting books about Storm I wanted to recommend. The Big Data by Nathan Martz is a very good read. Not only about Storm, but in general about big data. Highly recommended. And I wanted to leave you today with this. So data streaming algorithms can help you whenever you have a really large scale big data problems. So think about big data problems which are even beyond existing big data problems, because as someone on the panel session asked before, when we think about big data, we think about Hadoop. But to do your analytics on Hadoop, you have to store all of your data first somewhere on the storage. Data streaming allows you to analyze the much larger data sets that Hadoop cannot even analyze, because they are so large that you cannot store them. Second, you can use some of the data streaming algorithms that we talked about. So, you do not want to flip your coin for the next 10 years to use the statistics. You can just use hyperloglog, for example, for this. And most important, you can make decisions in real time. So thank you very much. This is my LinkedIn account, by the way. So if you want to stay in touch, please send me an invitation. I think we should have some time for the questions.
A couple of questions, yes.
Yep.
The rest of it maybe can be asked during the break time.
Okay, so 2 questions.
Yeah.
Both stream as well as batch processing. Also, the second part of the question relates to this, but it's about, for example, the message passing semantics in Storm is actually at least once. So, how do you deal with that in a real context? In comparison, Spark can give you exactly once. So, any comments on these would be welcome. Thank you.
Yeah, sure. So, about the second question, I will start from the second question. You can use in Storm something like transactional topologies, which gives you essentially exactly once semantic, meaning, if you replay some of the input data because it was failed for whatever reason, then you are not running into the risk that you will update the database twice for the same input data. So you can definitely do it with Storm as well. And the first question, the Spark versus Storm, well, I think it's a personal choice in this case, because Spark is based on Scala, and Storm is based on Clojure. So simply because I was more interested in Clojure, I decided to use Storm. And it was always working very well for us, so I never really thought about looking into Spark and using it in real life projects. But I think after today, actually, I'm quite curious. Like, I see like a lot of people are talking about Spark, so I will have a look definitely into Spark as well.
Hello.
Right.
Hi, it was a nice presentation. I just want to understand how do you handle the accuracy part when you work in Storm, because the accuracy is an issue. We cannot guarantee that, which we can probably do that in Spark comparatively.
Accuracy?
Accuracy of the data, the processing in Storm.
Okay. Well, I think your question is probably similar to the gentleman that asked his question as well.
You said that it's a matter of choice, but like if we really want to go for accuracy, then do we recommend Storm in that case? Plus, like if we have Spark, it comes along with the machine learning, like you said, you had R integration. We don't want to do that in Spark. Then we already have Open Graph over there, and besides that, accuracy is definitely there. Maybe the processing may be little slower compared to Storm, and in Storm we need to integrate with Kafka for any streaming part. So I just want to have a comparison if we can do that between that and deeper sense if you're comfortable.